Hey everyone, a very good morning and welcome back to my channel. My name is Akriti. So let's move on to today's question. This is the question number 1696, jump game 6, right? So basically in this question, we are given a zero index integer array nums and an integer key, right? So initially we are standing at the zero index and in one move you can jump to at most k step forward without going outside the boundaries of the array, right? This is like you can jump from index number I to any index which is less than or equal to I plus k, right? Inclusive. So you want to reach the last index of the array and your score will be the sum of all the index which you will visit while moving, right? So we have to return the maximum score which is possible or that we can get out of it, right? So here is an example. You can see initially you will be at 1 which is the zero index, right? Now you will move to such index that you will get the maximum score, right? So I can move to I plus 1, I plus 2. Yeah, this will be the maximum that I can move to. So suppose if I am at a 0th index, then I can move only to 1 or 2 index, right? I cannot move from further, right? So I have two options here. Either I can jump to index number 1 or I can jump to index number 2, right? So what will you prefer? Just because at index number 1 the value is -1 and at index number 2 the value is -2, right? So if you will move to index number 2 you will suffer more loss, right? So definitely I'll jump to index number 1. So here I will jump. Now when I am at index number 1, again I have two options. Either I can jump to index number 2 or I can jump to index number 3, right? Now again if you will see at index number 3 you are getting the more scores, right? Which is positive. So definitely you will jump from here to index number 3. Now if you are at index number 3, then you will directly jump to index number 5, because if you will jump to index number 4 you will suffer a loss of -7, right? So you will not jump. So by jumping this way from index number from 1 to -1 and 4 and 3, I'll get the maximum score of 7, right? So this is the maximum possible which I can get. So this is something which we have to do. We only have to make sure we do not go out of boundary and we can jump only up to I plus k index, right? So what will be your initial thought process for this question? Definitely the DP, right? You will say, yeah, I'll come to a particular index I, and at index I will have these many options. Like either I can jump to I plus 1 or I can jump to I plus 2 up to I plus k. I'll try all the possible ways and something which is giving me the maximum answer, I'll just store it in my DP array and I'll move on, right? This is something which you will think initially, right? So this is the code for this approach I have already written, and I'll show you why we are not going with this approach, right? So this is the code. I have made a DP vector. Okay, and now I'm starting from the zeroth index because initially we were at zero index. Now I will at index number I'll check if it is equal to the last index, right? Because this is our destination where we want to reach, right? So if this is the destination or we have reached the last index, then we will simply return the score or the number which is stored at that particular index. Now if something is already stored in my DP, then I will return from here. And after that I'll try all the possible ways. I'll say, yeah, I'll move to index I will move one step up to k step, right? I will try all the possible ways. So here I will check if it is not going out of bound, right? So if it is not going out of bound, then I'll run my function for the same. So if I am at a particular index, so definitely I will get the score equal to the number which is stored at that index plus the position which I am moving or jumping to, right? So here I am jumping to jth position from I am making the jth jump, right? So my next index will be I plus j, and yeah, the whatever the maximum I will get, I will store in my answer and I'll return it and store in my DP, right? So this is the basic approach which everyone can think of, but this is not going to work here, right? So let me run it and show you it is not working. So initially it's working, but later on it will give you TLE, so you cannot proceed with this step, right? Yep, here you can see it is given TLE, right? So this is not something we can do in this question. We have to change our approach. Now I'll tell you what we are actually going to do. Okay, so this was our example which we have already discussed. So we will be starting from the one, and we have to reach two, right? Which is the last index, so which is the fifth index, right? Now I'll make a priority queue where I will be storing the score of a particular index, right? Like suppose if you are at a fifth index, right? So if you want, we only want to reach the last index, right? Because last index is my destination. So my destination will always be equal to 5, right? Now we will keep on changing the source and we will calculate the maximum score which we can get, right? So suppose if you are at a fifth index, what is the maximum score you can get for reaching to fifth index, right? Which is the destination, of course. So I want to reach fifth index, and initially also I am at a fifth index, right? So maximum score which I can get is only the number which is stored here, right? Because I cannot move any index. It was not allowed to move backward in direction, right? We could only move forward direction. So there is nothing forward. It's mean I have already reached a particular index, then the maximum I can get is 3 here, right? Now so I will simply store whatever I get in my priority queue. Priority queue, this is a max heap. So the topmost element of the priority queue will always be the maximum among them, right? So in the priority queue we are storing the score at the particular index. So here I got 3 score at index number 5, so I have stored it, right? Now let's move to the fourth index. Now suppose if you are at the fourth index, then what are the options you have, like where you can jump from fourth index, right? So as it was given in the question, we can jump up to 2 steps, right? So either I can jump to 4 plus 1, or I can jump to 4 plus 2, right? So here you can see 4 plus 2 is going out of bound, right? Because this index does not exist in my array, so I cannot move to 4 plus 2. So definitely I will have to move to 4 plus 1, because this is the final destination which we have to which we have to reach. So at fourth index, the total score which I will get will be equal to the value at the fourth index, which is the -7, and the index which we are going, or which we are jumping at, which is my index number 5, and the value here is 3, right? So total value which you will get at fourth index will be around -4, right? Okay, so this is -4. Now again what I will do, I will store it in my priority queue. So the score is -4 and index is fourth. Now done, right? Now suppose you are at 3 index. Now we are starting from the rightmost index and we are moving to the left, right? So now we are at a 3 index. Now again we will check where you can jump, right? So I can jump either to 3 plus 1 or 3 plus 2. So 3 plus 1 is fourth index, which is this, and 3 plus 2 is fifth index, which is this. Now what will you choose, right? Definitely I will try to use the one which is giving me the maximum score, because once you move to particular index, you are the number value which is stored at that particular index will be added to your current score, right? So you don't want to add the negative value or something which is giving you less score, definitely. So what I will do, I will simply look at the topmost element of the priority queue, which will be storing the maximum till now, right? The maximum is score till now. So when I look at the priority queue, and I'll see, yeah, this is the maximum score which I can get. So 3 comma 5 is the maximum score. Now once I choose this particular element from my priority queue, I also need to check if it is not crossing my bound of k, right? Because if you are at the particular index, you can only jump up to k. You cannot jump more than k. So you will have to check if I plus k is kind of less than the index which is stored here, right? Only then you can jump to this particular index. So you have to check if it is valid, right? This is within the k steps, then you can choose this particular index, and if it is not valid, you will remove this from the priority queue and you will check for another elements, right? So in this case it was valid because from 3 you can easily move to 5. So definitely I will choose the maximum, which is the topmost element of the priority queue. So I will try to jump to directly 5. So the value which is stored at my 30th index is 4. So this will be equal to 4 plus 3 because I'm moving to index number 5. So here you are getting 7. Right, very fine. Now again, once I get the value, I'll simply store it in my priority queue. So as you can see, the 7 is the maximum among all the element which is already stored in my priority queue. So it will be the topmost element now. Now, yeah, let's move to the second index. Now, when you are at a second index, where you can jump, just forget about it. When you are at a second index, the value which you will definitely get is -2, because this is the element which is stored at that particular index, so you have to take it. So right, so -2 will be the minimum, and now you have to get, now you will try to get the maximum possible, right? Or you will try to jump at a particular index where you are getting the maximum score, right? So first of all, I will look at the priority queue, the topmost element. I'll see, yes, this topmost element is 7 comma 3. So definitely I will try to move to this index. Now again, before moving to this index, I'll just check if it is possible for me to move at that index, right? Because it should be within the k steps, right? So here you can see 2 plus k is less than or equal to 3, right? Because maximum I could move to index which is equal to 2 plus k, है ना? So here 2 plus k, which is equal to 4, is maximum, or you can say is greater than the 3. So I can say, yeah, I can move to index number 3, right? So I'll just move to index number 3 from 2. So from 2 I'm going to 3, and from 3 it can reach to my destination by getting the score of 7. This is something we are storing, right? I hope you got it. So from index number 2, I'll choose this element from the topmost of the priority queue, and I'll add it. So -2 plus 7 is going to be 5. Yep. So this is also I'm going to store in my priority queue. So this is the second maximum element of the priority queue. So I will be storing it at the second position. So 5 comma 2. Right. Now move to the first index. Now at first index you have -1, so you will definitely take it. Now you have to choose where you can move, right? So from first index you can move to index number 2 or index number 3, right? Now you will look at the topmost element of the priority queue. So here you can see index number 3 is available with the maximum score you can get up till now, right? So definitely you will choose the index number 3. So from 1 I will choose to jump to index number 3, and from 3 if I have to reach the destination, the maximum score I can get is 7, right? So total score at index number 1 will be your 6. Okay, so 6 I have stored here, and I'll store 6 comma 1 here. Fine. Now you are at index number 0. Now, now here, just observe one thing. You are at index number 0. You will go to priority queue. You will check the topmost element, which is the maximum score. So you will check the topmost element is 7, right? Now, before moving further, you will check if it is within the k steps or not. So from 0, you can either jump to index number 2 or you can jump to index number 1, right? You cannot move any index which is greater than 2. But here you can see in my priority queue, the at the topmost element my index is 3, right? So we cannot jump to index number 3 from index number 0, definitely. So this is something which we cannot choose, so we will remove it from our priority queue, and we will check for any other element which is maximum and which is within my k steps, right? Now once I get the 6 comma 1, I'll say I can move to index number 1 or index number 2, right? So here you can see for this element my index is 1 only, so I can choose this index which is the maximum possible which I can get from here, right? So my answer is going to be 7, because 1 plus 7. So this is the final answer. And now you can see if you are at the index number 0, then the maximum score which you can make to reach the destination is going to be 7. So this is my answer, and here also you can see the answer was 7. Right. So this approach we are going to follow for our question. Now, basically, we are making a DP array only, right? We are not doing anything other than this, but in a different way, right? So here you can see this particular array is my DP array, and here we are storing that suppose if you are at a particular index, let's say index number 2, then the maximum score which you can get for reaching a destination is going to be 5, right? So here we are storing the maximum score which is possible for us to get for reaching a destination, right? So let's code it first. Let's make it array. Okay, let us say n be the number of element in my array. Now, if my n is equal to 1, like we have only one element, then definitely the maximum score we can get is equal to array of 0, right? We don't have to do anything. Now let's make a priority queue. This is the max heap which we will be using because we want that the topmost element should be maximum. Now initially I'll push in my priority queue, which is the which we have initially pushed, right, which was 3 comma 5, because if you are at the last index, then this is the maximum score which you can get, right? So initially I'll push array of array of n minus 1 comma n minus 1. This is my initial priority queue. Now let us say my index is n minus 2, which I care about. So while my index is greater than equal to 0, I have to keep checking, right? Now while my priority queue is not empty, and while the topmost element of the priority queue is not within the k steps, right? Because we could move only k steps further from a particular index. So if the topmost element of the priority queue is after k steps, or the index which is stored at the topmost element is beyond the k steps, then we had to keep removing the element, right? Because we cannot go there. So if not a priority queue, and pq dot top dot second, because in the second part only we are storing the index is greater than my current index plus k, right? So we will simply pop the element from the priority queue. Now I have to check if my current index is equal to um 0, right? Because this is the last index we had to because this is the last index we had to go till, and we have to find the answer of the index number 0. So we will only go till index number 0, right? So we will simply return my answer. Let me just find the answer. What my answer is going to be, let's say this is answer is value, and which will be equal to the topmost element of the priority queue and the current value which is stored at my particular index, right? So if I have reached the index number 0, then I will simply return the value. Otherwise I will store it in my priority queue. So this is going to be value and index, right? So at this particular index this value you will get, right? And I have to do index minus minus because we were moving to left. Let me just change this bracket here, and here you will be returning minus 1 if you doesn't get out of, if you doesn't get anything from here. So yeah, it's working now. And now you will see it is not going to give you TLE as it was given in the previous submission. So yeah, it's done. So yeah guys, this was the whole solution. Before wrapping it up, let me just summarize what I have done. So basically we have make a DP vector where we were storing that if you are at a particular index, the maximum score which you can get to reach the destination. This is something we were storing here, right? So if you are already at my destination or the last index, the maximum score which you can get will always be the number which is stored at that particular index, right? So which this is 3. Now once you move to index number 4, you can only move to index number 5 or 6, right? And just because 6 is out of bound, then you will definitely move to 5. So the number which you will get will be the number which is stored at index number 4 plus where you are going to move, like. So it's like dp of 4 will be equal to array of 4 plus dp of 5, right? This is something which we were doing. So it's like if you are at a ith index and you want to jump to jth index, so the maximum score which you can get to reach the destination from the ith index will always be equal to dp of j plus array of I, right? So this is something which we were doing for the entire solution. Now the priority queue we have made to make sure we will always choose the one which is giving us the maximum score. So we have make a max heap which will simply give you the maximum score as a topmost element. Now if the topmost element of your priority queue is going out of bound, then you will keep removing them until you find a valid index, right? So this was the entire solution. Now if you have any doubt for the question, you can ask in comment box. Thank you so much for watching. Have a good day.